So I'm going to put our kind of formula up here. You will have needed to have gone to get this from your notes. Our amount in our account, that's our principal balance. 1 plus or minus our rate over n to the nt. That's the equation we're using here. And you guys are going to be substituting in the information and finding the values. And the only thing that's different on all of these is our n's. So I want you guys to find the balances. That's what you should have been doing. Only thing that's different is the n. So let's talk through the n's. What is our n when it's annual? 1. What will our n be when it's quarterly? 4. What will our n be when it's monthly? 12. What will our n be when it's daily? 365. Here we come, my slightly obnoxious ones. How could we find out hourly? Yeah, how many hours in a year? Well, I know how many days we have in a year, right? How many hours are in a day? 24. So we could take our 365, bless you, times 24. And that's going to be our n. We're going to multiply that out. All right. This one's for my little theater heart. How many minutes are there in a year? 525,600 minutes. Song about it. Okay, so when you're calculating these balances, which we are going to get all of these balances, the n is the only piece that changes. What is our principal? 1,000. So on every single one of these, when we're writing this down, when we're calculating out the values, we're going to start with 1,000. 1. Are we going to add or are we going to subtract our interest? Oh, it doesn't actually say, does it? Our only clue here is that it's a savings account. Savings accounts almost always earn interest. I will make sure when we have any sort of assessment that it is clearly stated. What is our rate? 0.04, because we read it as a decimal. Since we're going to be doing this like 6 times, I'm just going to put an n here so we remember to change our n to the n. And after how many years? What's our time? 10. That's our piece here, times 10. So for all of these, we're just going to take this to find the amount in our account, and all we're going to do is change the n. So we're going to type this in the calculator, yes, 6 times. Which means my don't feel like calculating. All right, here we go. Get a calculator. Go. Because you're supposed to have calculated these values. You're not supposed to be waiting for me to do it. So do it now that we filled in the equation. Find the value. We wrote the equation, we find the ends. All you have to do now is type them in. So take like 2 minutes and straight up type these in. to your calculator. Ooh, that one's got dead pixels. Bless you. Because we're doing this for a reason. It's not just because I like to torture you guys. I promise we're doing this for a reason. So I want us to notice some things. Let me check the list real quick while y'all finish this up. Because I think she sent it out Friday. All right. So what are we noticing about these balances that you got? Do they keep just getting bigger and bigger and bigger and bigger and bigger? They're still going up, but they're like squeaking up at the end. Because what did we get for, like, annually? And 24 cents, yeah. And then when we got all the way up to minutely, the very last one, what did we get there? Yeah. We're getting values like this. So it's still going up. It went up $8 between annually and quarterly, but then it only went up $2 between quarterly and monthly. And then only another $1 between monthly and daily. And then it was just a matter of a few cents. And then it doesn't even seem to hardly go up at all. If you looked at your decimals, it did go up, but like barely. So what we're seeing here is that even if we're changing our compounding factor, there's kind of a maximum. Like there's a most amount we're going to get. As we get closer and closer together, it doesn't seem to change all that much. And because mathematicians be crazy, they figured out a number for that, for the fact that it can get as close and close and close and close and close and close as possible, and still technically be changing and be close as possible, but we don't need to like memorize the whole kind of stuff. Okay, so there is a maximum amount of compoundings that it can do. I can take it daily, I can take it hourly, I can take it minutely, we could go secondly, we could go millisecondly, we could do this. And what it's really doing is it's approaching being compounded continuously. Forever and ever, it's happening at every millisecond of every day. And you would think that should be an infinite amount of interest because it seems like an infinite thing, but they've made a number for it. And that's what we're going to talk about today so that we can not have to do this when we're doing so many flippin' numbers. I will never make you type 525,600 minutes into a calculator again. That's just from my little Reinhardt, because that's a theater show from before y'all were born, but it was like my childhood. Okay, so what we're going to do is we're going to introduce you to a number we call E. And the dude who came up with it, his name was Euler, which is why it's an E. And we treat it like pi, but it is used way less frequently. Like pi we use all through circles and all the geometry, like all the things in geometry. E is pretty much only used in this chapter and next chapter and then college stuff. You do not need to try and memorize the value of E. It is in fact a button on your calculator. It is 2 down from the green button, but it's in the little green text. It says E to the X. And so you don't need to memorize the number. In fact, I looked it up. I don't remember the value of E. I know it's 2.7 something, but that's as far as I get. Like, not the math party trick. Okay, and so what we're going to do is we are going to treat it when we're solving things like a variable, and then use our very bestest friend if we ever need a number part of it. Okay, we will never be calculating E by hand or anything with E to a decimal point by hand. It's always going to go into the calculator. But we're going to start out practicing using it in place of an X, and then I'll show you how we really are going to use it. So we're going to treat simplifying problems just like we did when they were X's. We just start to get a little scared when we know E's a thing. So if we have e to the 7th times e to the negative 2, what are we going to do with these two exponents? Back to the exponent law stuff. What are we going to do with these two values? More specific than combine. Not quite multiplied. That's when we have a power to a power. So if I had e to the 5th squared or something, then we would multiply. When we have a power to a power, that's when we multiply. We add them together. Think of it like when we had x to the 7 times x to the minus 2. We treat it exactly the same way. We're going to add these exponents together. Ooh, the purple and the blue are too close together. I'll lighten that one up. There we go. That at least looks different. So what we're going to do is we're going to take and add our exponents here. So we're going to have e to the 7 plus negative 2. What is 7 plus negative 2? 5. So if it helps, you can switch it over to x's and then switch it back at the end, but I think that's doing a lot of work. But sometimes to look at it this way makes us think of it. And that's where we're going to have our answer. We are only ever going to get numerical answers when we're dealing with like story problems. And I promise I will show you what those look like. Bless you. What about when things are in fraction like this? What are we going to do with our exponents? Been a minute since we looked at this. We do subtract. When we have bases that are being divided, we're going to subtract. So for the just e part, what we're going to do is e to the 5 minus 2. How about for our numbers part here? What is 36 over 9? It's 4. We can just simplify that piece. So it's going to give us 4 e to the 3rd. Bless you. Allergies are acting crazy. My allergies are also allergying today. It's a whole lot. Okay, so when it's in expressions like this, we're just going to treat e like we would any other letter. If it was an X, if it was an R, if it was S, if it was a T, it don't matter. We're just going to treat it like any other variable. Two more, and then I'll show you why the heck we have this and why I'm going a little crazy on it. All right, so we're going to simplify again. We've got another multiplication and another division. So we have e to the 4th times e cubed times e. What are we going to do over here? 4 plus 3 plus 1. So whenever we have exponents of the same base, we just add the exponents together. So e to the 4 plus 3 plus 1 is e to the 8th. So when we multiply our bases, we add our exponents. And when we divide our bases, so on the right-hand side, what do we do with our exponents over here? Subtract. So when the bases are the same, we subtract our exponents. E to the 6 minus 2. How about for my numbers part? Yeah, 60 divided by 12 is just 5. So we think of it in pieces. So we're going to wind up with 5 e to the 4th. We're going to start seeing e pop up really heavily through the next chapter as well. So it's going to show up. We treat it just like a letter until it comes time to put it in a calculator. We remember that it is a number. It's kind of like pi. It doesn't feel like a number. It doesn't look like a number, but it is a number. So the reason we care is because this is the number that they found for that kind of most amount of interest we can ever receive, no matter how close together we put together our compounding units, no matter how tiny I cut the pieces. It's always going to approach e. And so what we actually wind up with is a new formula for interest. Yay! I think this is our last formula. I can't guarantee that, but I'm pretty sure this is our last formula for interest. Only 3. And again, we have a lot of the same pieces, but some of them are arranged really differently. It still equals up to the total amount in the account. We still are going to have our principal interest out in front. So our principal is still out in front. Then what we have is that we have our base is e. E is a button on our calculator, but that's the base. And then into the exponent goes our rate as a decimal and our time. So both of those are up in the exponent, and those two are multiplied together. So PERT. Principal times E to the power of RT. PERT. I can't not say it weird. PERT. Yes, dear. E on the calculator is, you have to hit the green button, and then you have to hit the one that has the little L on it. It's teeny tiny buttons. It's 2 below the green button. And I promise we will use it on the calculator. We're going to start with writing the formula and typing it into the calculator using story problems. And I'm going to make sure that I got the calculator open. Get that Okay. So really this is our last compound interest formula that we're going to use. And again, I'm going to give you all the formulas on the test. You just have to know how to use them. So here we've got $1,000 compounded continuously at 4% in 10 years. So we're going to start by filling in the pieces. The amount in our account is, what's our principal? 1,000. That's our starting amount. Then we put E, which is just a number. So we're going to still have the letter E here. Then we're going to take our rate. What's our rate? 0.04. That goes into the exponent. 0.04 times our time. 10. Oh, that seems like a really familiar situation. Then let's go find this balance. So we're going to type it in the calculator. We're going to have our 1,000. To get to E, you hit the green button, and then it's 2 buttons down. This little one that says L to the N, or LN, gives us E, and it will always automatically pop you into the exponent, because E is always going to have an exponent. In this case, our exponent is 0.04 times 10. And we get 1,491.82. Oop. 1,491.82. Huh, that number seems awfully familiar. As our compoundings got closer and closer together in our bell work, we noticed that it stopped kind of changing as much because it got really, really close together. But these equations were obnoxiously long and a pain in the butt to type in. Oh, snap. Same situation. Way easier equation. So when the compounding is happening continuously, I will never again make you do a hourly or minutely or secondly. That was the only time. It was to prove a point. This gets us there. It gets us to the same value as to when it's compounding continuously without near so much work. So when we're given problems like this, and this next one's going to be the last one, we're often going to be asked to figure it out more than one time. We're going to figure it out annually, we're going to figure it out monthly, and we're going to figure it out continuously. And these could be different. Sometimes it's semi-annually, sometimes it's quarterly, sometimes it's monthly. Sometimes it's daily. But we're going to figure it out, and we're going to use our formulas again. So we're going to practice utilizing those formulas. So we need to have both of them. Our two most common ones. Our principal, 1 plus or minus r over n to the nt. And we're going to have our Bert. I can't not say it and make it sound like Bert and Ernie. Bert. So we're going to fill in these equations. For our annually, we're going to need to use our regular compound interest formula. What is our n going to be when it's annually? 1. So when we write our equation, we need to fill in all the pieces. What is our principal balance? 4,000. So when we start filling out our equation, it starts with a 4,000. We know it's paying interest. So we're going to use a plus. This one gets our fraction. What's our interest rate? It's the 5.4 or 0.054 over our n to the power of n times our t, which is 8. So to calculate this annually, we straight up type them in as they are. 4,000. 1 plus the fraction 0.054 over 1 to the power of, that's not powered, to the power of 1 times 8. And you can just straight up type it in like this. And we get $6,092.35. 35. Hey, I did remember right. So annually, we can plug in the information. For monthly, what does our n change to? 12. The only difference is that n is going to be 12 instead of 1. So everything else is the same. We still have our principal of 4,000. We are in a savings account that grows. We're using our 0.054 as our interest rate, but our n is now 12. And we're going to raise it to the power of 12 times our 8. So again, we're going to type it in the calculator. We're going to have our 4,000. 1 plus our fraction 0.054 over 12, bless you, to the 12 times 8. So we typed the whole thing in, and we are super duper careful, and we are going to slow when we type things in. We've got 6,155 and 37 cents. 61, 55, 37. These two are what we did all last week. This is our chunk that's new to today. This is where we're going to take this equation here. And it has all the same pieces. The amount in our account is our principal. It's the same principal. We're going to have our 4,000. Then we have our base of E to the power of our rate, which is that same decimal rate, our 0.054 times our time, 8. So whenever it's compounded continuously, the whole equation is different. It has less pieces. So we're going to type it into the calculator. We're going to have our 4,000. And then we can hit the green button, and we hit the little ln. And we're going to get e to the, and then we put in our values. Our rate is our 0.054 times 8. And we're going to type it into the calculator like this. This step that it was in my keys was right here, was super important. Where we hit the green button and then we hit the ln button. That's what gives us our little bitty e. So we got to know how to type this in because you will be asked to compound interest continuously at some point on the test. You will. You make sure you know how to find the e on the calculator. Super duper important. And we get 61, 61, 34 for our balance. 61, 61, 34. So it's another way of calculating interest where we take the smallest possible end values. Yes, sir. Yeah, let's test machine. Okay. So that is the end of today. I'm going to pass out homework 7-3. We're going to go through more continuously compounded interest tomorrow. But I'm still going to pass it out. So you guys can do everything on this, but we'll have a couple of different kinds of scenarios tomorrow. So there's a couple short problems you can use on what the heck it is. We'll talk about it tomorrow. But it's just going to be with E. So tomorrow we're going to keep working with E and all that jazz. Ooh, they want to look crazy on my tables and music guys. These are close. I do have a pull on aisle to strip it over here. What's up? Yeah. Yes, dear. It does. So how often does that happen in a year? Because the whole thing is how many times does it happen in a year? We don't want to put it as like a 6. So what's our n going to be? How many times in a year would semi-annually happen? Thank you. Do you think about like the Bath and Body Works semi-annual sale? That's pretty much the only one I know of. Happens in like spring and like fall. So how many times a year does it happen? 2. Yeah, so semi-annual is going to be 2. Okay.